Hi, Jimmy. How are you? We have about a minute, so let's check out your notes and your assignment, and then let me take a look at Lab 11 issues. Okay, good. Glad you're doing well. Yeah, it's possible that the JSON, this part, doesn't exist anymore, so I will replace it with something else. So let me rerun the code later on today, and then I'll follow up. Yeah, that's what I'm assuming, because sometimes they remove content from websites, and that's what happens with the API. Okay. All right, so we'll go ahead and get started. So this week we are going to learn how to do web scraping, and let's start with notes. Sorry, I'm flipping through the documents. So this is going to be chapter 12. I think when you get into different areas, like if you get into web development or even in data analytics and cybersecurity, you would see that web scraping is really useful. So in this week, we're going to focus on working with HTTP and how to look at web requests from the Python programming perspective. Okay. So in your notes, starting with the beginning, that will cover the chapter 12. It talks about web scraping, and this is a way that we can quickly extract data, and we automatically use web requests from the pages. So you can do it for many websites instead of opening your browser, typing in your URL individually. That would take time. So we can use Python to automate a lot of this process. So this will allow us to use the request to visit the site and then comb through the list of the sites to be able to pull data. You can find a lot of different data repository, but if you need to pull data from specific website or your company's website, this is also useful. So this is how we can collect the data for analysis, and keep in mind that we're only going to use this to get data and information. So this is not going to add into the data analysis part, as we touched on some of it earlier on. So web scraping is useful, and some of that is going to require you to understand a little bit of HTML programming. Some of you might be familiar with this, but if you haven't, it's really simple. So HTML is your hypertext markup language, and currently we're using version 5. So we would be able to create web pages using HTML, or understanding HTML allows you to understand the content of your web pages. So when you visit a website, your home page is created using HTML as a file. And you can write your HTML file in any text editor, or if you have your IDE, you can create your HTML file, and you just simply use the .html file extension. So I would save it, for example, as page 1 or contact information, etc. Now it uses tags, and the way that HTML indicate tags, the syntax for it is you would use the arrows. And so here you can see that we are going to italicize. P stands for paragraph. And then occasionally, if you see photos or image on the page, you would see the tag img. And just like all the other programming languages, what you see is you want to organize your content in directories, and your files need to be together in order to access one another. So you can also, as you use tags, you would have an open tag, which would be like this. And then when you see the closing tag, that will be like with the slash, like this. Okay. So that means that when I use tag, I would start with an open tag. And at the end of that section, when I finish with that tag, I need to have a closing tag. So the example that you see would be here. And as you can see, we have some closing tag there, right? Open tag here. And you can also reference different files that would be linked to your page. So if I want to be able to have like a URL, I can also reference it. I can also add in my image. So you would see image source like this. And your image file needs to be in the same folder as your HTML file. So this is an example of what you would see with HTML. Now for HTTP requests, we slightly touch on this when we looked at how to visit the website using HTTP. We're going to dive a little deeper and we're going to talk about HTTP header and how the process behind the scene for the web server. So when a user visits a page, usually they would use an application like your browser. It could be Chrome. It could be your Firefox, right? It could be Bing, etc. So when the user visits a site, the browser would submit the methods to the web server, and the web server is going to receive that request, and it's going to respond to the client request. So you as a user open up the browser, and that's considered the client system. And we type in the URL. That URL is going to then be submitted as a request to the web server. And so the browser would then receive the response back from the web server as an HTML document. So when we visit, for example, youtube.com, we type in that URL. The page that's served back to the client on the browser side is the response once it's confirmed. Now, HTTP, a little bit of this with the networking side is that it has to be fully, the connection has to be fully established, meaning that you have to have complete communication in order for your server to serve you back the page, what you see on your browser application. So your browser would then take the HTML document and then interpret it and output what you see on screen. And so the server itself would contain many of the HTML document. So let's say that Google server is used to host that particular website like youtube.com. What you would see is that server would have a public IP, and that public IP is tied to that particular server. Then that server would contain HTML file, would then be used to serve back to the client, so that way the browser can interpret it and show you the content, videos, things like that for youtube.com. So in the request methods, what you would see is that it would require some of the actions, or what we would see as commands, for the server to be able to communicate. So you would see get, head, post, put, and delete. So for the two common methods that we see for web scraping, that will be your get and post. So when you visit a site, when you initially type in the URL, that request goes out to the server. That's considered a get. and that simply makes the request to the server. And so within that process, what we would see is that it's going to retrieve the data, which is your HTML file, and there is no other effect to the server and its database. So we can obtain the information using GET. Now, what if you type in a form? Let's say that I'm filling out my financial aid information using for FAFSA, for example, or when you're registering for an account online. That's considered a post. So when the users submit the data that is accepted to the server, that would be a method post. So the data would then be sent as message through the form, and some of that data would go into databases, right, to maintain the records for that particular user account or that account information. So if I'm filling out my financial aid, right, once I log in and I added in some tax information in the form, what happens is whatever I input, right, it's going to be stored as different fields into our records for our database. Now, you don't necessarily have to use posts for forms and extract that to or send that to the database. You can also submit bulletin board, or when you're posting things to social media, if you're using social media website, right, that's also considered a post. So any form of information that's submitted to the web server and it accepted by the web server is going to be a post method. Okay, so let's switch gear now. Let's talk about the assignment. So for number 1, it asks you to describe the purpose of web scraping. And web scraping is a form of data extraction or data extraction method. This allows you to automatically make requests to different websites or web pages. It doesn't necessarily have to be a site. It could be multiple pages from the same site. Because when you go to data.gov or different data repository, you would see that they would have many different pages that would contain useful data, possibly for your research or your analysis. So it simply allows you to make the request to the web pages. And within on those pages, if download is allowable, then you would be able to download the data that you need. So this is definitely useful. We can probably extract data from hundreds and thousands of web pages all at once in one script. And I will show you how you can do that. So it lets you comb through different sites, different pages, and be able to obtain or collect data that's needed in a systematic manner. So we can pull them down as files. We can also automate that and put those files into possibly CSV format. And so there are many ways that we can do this. So it creates more of a convenience for us to really pull the data. And for number 2, it asks you to describe the HTTP process in obtaining data between the client and the server. So your system is considered a client system. And so the client system browser would then send request methods such as GET to the HTTP or the web server. Now, an organization might have many web servers, right? Because we can't rely on one for something as big as Google or Microsoft, right? What you would see is that they would have many of the servers in that particular domain to be able to serve. And so when you submit that request, the client system simply is asking for data from the web server or the website. And so what the browser receives is going to be the HTML document or the HTML file, which is then being interpreted on your browser as what you see as images, text, videos, etc. on screen. So the application itself as a browser, its job is to be able to pull, right, to send the request. And then once it receives the response, it's going to then take that HTML document and then interpret that and display it on screen for the user. As we talked about the common methods for web scraping, you see that for web scraping, you would have GET, which is make requests for specific data from the server, and POST is to send data in specific form that is accepted by the server. Now, some website, as you know, contain static pages where it doesn't receive any kind of input from the user, so there is no POST method allowed. But there are web pages from a website that is able to accept POST or in forms, right, or in fields that the user can input. And so with that, what we would see is it could be converted into different format or text format, right? So what you see is that that would be allowed for that particular website. Any question regarding HTTP processes, methods? Okay. And all of this information you can find at the beginning of our notes for Chapter 12 or Unit 11 notes. Okay. So let's come back here. Now, in the back, what you would see is there are status codes that are used to determine the type of response that's being received from the server. And these are just 3 digits. So most of the time when you visit a website that doesn't exist, for example, if the user had typed in the wrong URL, right, and it's not able to locate the web server, you would receive like the 404. That is a status code, page not found. So that's commonly seen by the user. But when you submit a request to a server and you have a successful response, the server actually sends back a status code that is a successful request. So what you would see is that it's broken into 5 different categories for these status codes. The 100s, so when you see starting with the 1, and it could be 102, 10, etc., right? Like 100 and up, okay, before the 200. This is just simply requesting different part of the traffic. So 100 is the header. Think of the header is like your postal mail, where the envelope contains the user or the sender and the receiver address information, like zip code, address, street name, etc. So the header contains information like which client is requesting, where is that traffic coming from, and which destination or which server is supposed to receive. So when you type in the URL in the back, it's going to look at, oh, what is the public IP for that particular website? So some of that information is stored onto the header. And then it also have like time to live, how long that request is going to go through. If that request is being delayed, right, exceeding the time to live because it is TCP, it's going to try to resubmit or generate an error code. So The server is going to be waiting for the request body, which is a separate portion, right? Think of the header as like the envelope that contains the information about where it's coming from, where it's going to. And then the body would be more of the content, what is requesting. And then 102 is another status code. And this is for processing. So it's currently processing the request. So in the case where I have very large requests, right, instead of being timing out, what it's going to respond, it's going to give you the 102. It's working on it. Okay. Now on the developer end, you're going to see that we track the status. So that way we would see what's going on with our web server, right? So let's say that you're testing your web server and you wanted to see if it's responding and how long it's going to be responding to specific requests. Then you can monitor the status code this way. Then the 200s, so 200 and up before 300, this is for receive. So when the server received the request and it's being processed by the server, you would receive the 200. So whenever you get the 200, 200, that is, it is successful. And then 202, this request is being processed, but it has been accepted, not complete yet. Okay. Then we got the 300s. So this would require additional actions to be taken for the request to be successfully processed, possibly some confirmation, or in some cases, when you see CAPTCHA or reCAPTCHA, right, you tend to see some of that, where it wants to check to see if you're not a bot, right, from the client system. So there is some action that would require the user to select the right picture for CAPTCHA to make sure that the user is there, human, not another system to system, right? So for 300, there are options in the response for the server to be processed. So it's pending what additional actions is going to be required. Then the 301, if you move the server and all the requests is redirected to another public IP address, then it would send the 301. And in the case where, you know, companies do this all the time, where it could be that they're merging or they bought out another company and they're no longer using that hosting company. For example, I previously used AWS. Now I'm with Azure or, you know, another cloud company. Then I would have my server moved. We're still going to use the same URL. It's just going to interpret it with a different public IP. So we re-register it with a different IP. It's kind of like how when you move your home and you go to the post office and you would tell them that you would change your address, right? You still are the same person. You're just going to move to another location. So the post office would know how to forward it. So we have to set up a way that we can redirect, right, to another public IP address. Then you got the 400s. This is going to be the error area. So if the request is incorrectly formatted, you often see 404, where it could not reach the actual server, right? So whenever you receive the 400s, that would be some error. Incorrect format, or when the client sends a bad request, or the request is not supported by the server. And then also in the 500, this is the error status for the server. So if the server cannot process the request, and this for the security side, we like to look at this area is because if you have DDoS or DOS, on the development side, you would see the response like this when you're testing your servers. So if the server is not able to respond, so first initially, it's going to send status code that it's working on it. And then eventually it's going to get so flooded that it's going to give you like 500 or the 504. So when you get like an internal unexpected error, or sometime when it has buffer overflow or RAM issues, even hardware issues, or it's running out of storage, stuff like that, you will see that it's going to get it's going to generate the server error code. Okay. And who manages all of these public information, like the public address to the URL? So registered, the DNS is registered. The DNS is maintained as a list to all the systems that are hosting. For example, I would have an IP address that would tie to google.com, right? That is being managed by your Internet Assigned Numbers Authority, your IANA. And this consists of, they would manage a list or a registry. So when you're using a web hosting company, they actually have domains that are set up with the public IP already. All you have to do is you would choose your domain name, and then once you have processed that service acquisition, they would tie that domain name to that public IP, and it would update the list with IANA. Okay. Any questions? Okay, so now we are going to go through number 4. Determine which HTTP response code is sent by the server to the client for the following scenarios. If the request is being processed, you would see status code 102 for A. And if the server is moved permanently and all the requests should be directed to another address, that will be 301. If the client sent a bad request, that will be 400. And if the request method is not supported by the server, which is 404. So when I type in my URL and I type in a wrong extension page, right, a page that doesn't exist, then it's not supported. It doesn't exist on that server. That file does not exist. So it would say 404. And then internal server error in which an unexpected conditions was encountered, that will be 500. So that's the server side. And so as we work with HTTP requests, what you would be familiarized with are these status codes. And so when you look at the output, you would see some header information, and in some cases we would have it output the status code so we can see whether it's successful or not, right, on your IDE. And so we want to check the status code to see how our transmission with the web server would be. And so when you do web scraping, let's say that I'm scraping from 100 different websites, right? And I might receive some that is error or bad. So that means I need to go back and check the URL or check to see if, you know, certain things, certain content, or maybe I have a typo in the URL, etc. So we want to check the status code. Okay, so now with this, we are using another module. HTTP have quite a few, actually. So the ones that are presented in this class, you're going to see that these are the common ones for HTTP requests or working with web server. But there are others modules that you would use with Python. So the one that we're using is going to be requests. So to install the request module, right, you can simply do pip3 install request if you're using like Linux system. And then if you're using IDE, you simply bring in the package like how you normally would, right, installing the package. So you would search for that package and then click it to download. So that way you would have it linked to your IDE. Okay, so I'm going to swap back to here. And so I put the documentation for your request. Let me see. It didn't. So I'm getting an error, as you can see there. How ironic. Let me relink that for you later on. So, but what you would have is you would be able to check out the documentation. It walks you through on how to install, how to work with it. There are examples of it that you can use. Okay, so to start, we want to make sure that that package is available. Okay, and then as you program this, you would see that first we got to import in that module request. And then you are going to use a variable or a list. So in this case, we're only pulling data from one website, which is google.com. Now, some website would require you to authenticate, right? So then you would have to put in the credential information and you can automate all of that through Python. So here we have a variable that's our URL and then our website. So our fully qualified domain name. Now you want to have a container that is going to store your request information or the response information, I'm sorry. So with this, RES is going to store what the server is responding back. So with that, we are going to use request module and we're going to use get method. And we're going to pass the variable URL. Now we simply would print, and this is an object, so we would then be able to use that object with the status code, and status code comes from the module. And then we also want to print out the headers. Okay, so header information would contain like the details in that request. And then what we also want to do is here is the with statement that we talked about last week. So we want to have the with statement and we're going to use it to open the HTML file. We're going to store it, write it. So once I visit the site, it's going to save a google.html file to my system. Okay, this is not necessary, but if you want to get the HTML file, that's how you do it. And then you are going to finish it up with, because you make it as an F, which is your object, we're going to write it as text. And then we want to notify that it's done. So when we run this, let me clear this. So this is the program. Okay, and then when you run it, you would see, let's pull this up a little bit so you can see. Here's my status code. That's what we told it to print. So it is successful. And then it would give you the timestamp. So the time that you access or you submit that request. And then also cookie and cache information. It also tells you the server information and its security. Okay. So here it creates a cookie, and that could vary too. If that cookie already exists, it will just update it. And then it tells you the expiration for the cookie and then the domain path. Okay. So header information is very useful for those of you who are interested in security. We look at this all the time when we, whether you're doing forensic or when you're tracking things web traffic. We look at the time that certain web servers visited, cookies that are stored, information about that particular request. Okay. So when it finished, it prints done. So that's what you see with our code here. And so you can do it for any website that uses HTTP like this. Okay. And so when it responds, it will be giving you the header like this. Any question? Okay, so that gives you a little bit of explanation on what's going on there and also here. So when you see the length, right, that's the content. So that will be the body. Now, after I ran this code, I should be able to see my Google file in the same folder where I have my script, my Python script. So here, I'm going to open this with Notepad so you can see. This is the HTML document that we saved with the open statement that we created. Okay. All right. So now some of the things that we also should use when we're using HTTP is we want to test it. So ping test is a way that we can see if it is responsive. In networking, we would ping a system, and if that system responds, then that system is connected and alive. So similarly, what you see with all the web server in the world, right? There are approximately 7 billion websites that are available worldwide. So what you have is you would have ways to be able to implement tools. And we can check the status code from what it's given back. So it's always a good practice to use your status code when you're doing ping tests. So when you're writing web applications, you should test your application and see how your systems are responding, especially your web server or any related server to the web server. All right. So in this example, we are going to write a ping test. We are going to use request module, as you could see with the import statement. And we simply write a function called ping. And we would pass the URL. And in this case, we're testing, right? We're testing this particular domain, which is http://stat.us. And in the function, similar to the last example, you would have the RES to store the response from the web server. And you would use request.get. So it's going to submit the URL to the web server as a request. And then we want to print. So in this case, we're going to format and we're going to output as text. Now, because this is a list of URL, we can't just do it with one. We have to loop through it. So we would use the for loop. We would say for URL in URLs, we're going to ping each one. And then we want to print done. Okay, so let me run that for you. That's clear. Okay. So as you can see, when we're adding this to the status code to the URL, it tells me that with this status code, it's okay, right? But when I'm using 400, it tells me that status code for this website means it's bad request. And then not found for 404, we know that, or 408 is request timeout. And then 500 internal server error, and then timeout occur with 524 for the server. So this is one way that you can find out how to use status code with a certain domain or web domain. Simply do a ping test. Okay. So that means that it's connected, it is responsive, but when we use it with the 400 or the other codes, right, it's going to give you the specific for that particular code with that domain. And then lastly, done. So in this example, you saw that we're using a list of URLs and status code, right? And then we wrote a function here for connection to the web to ping it. So to check its request to see if it's responsive. Now, we don't just stop with synchronous programming. The whole point in this is to show you how you can do this concurrently. As we've been working on parallel programming, concurrent programming, and implementing threads and multi-processes. So to really build out what we've been learning, we think about how we can write this as a concurrent program. So you can apply parallel programming and concurrency to how you're testing your application or even using HTTP requests. So in parallelism, what you would see is instead of waiting for one request to go through and then receive a response, you can actually submit multiple requests at once. And that's the whole point, is to be able to handle many requests at the same time. And that's what's cool about it, is that we don't have to do it one by one, which is tedious and time consuming. We want to maximize the capability of our system and the server's response capability to be able to respond, because the web server, its job is to be able to respond to all the requests. Now, if you think about it this from a security standpoint, right, to really cripple a web server is to submit nonstop many different requests. And that's how a lot of the attackers take down web servers. So when they're doing denial of service attack, simply it just submits hundreds of thousands of requests at once to that server. And the server is so busy responding to that request that it eventually can't respond anymore. And so that becomes a denial of service. But when they're doing distributed denial of service, that means that they're pulling a lot of systems around the world, right? Many systems, bots or zombies. And those systems submit thousands of different requests at the same time. And so the concept in programming is the same, where if you implement concurrent programming, you can submit many requests at once. Am I telling you to write this as an attack? No, but from a security standpoint, if you know how to write this script, you can test your system to see how long it will withstand denial of service attack. So if you're looking into developing for cybersecurity, right, through Python programming, you can think about how we can use concurrent programming to test denial of service for the web server this way. Okay. All right. So with that, we would need to implement threading. And you would use request and threading module. You saw this in the last few weeks, also last week. And with that, we simply implement the function, just like what we saw in the last example. And in this one, we're going to time. So we implement our clock. So we're going to start the clock. We're going to ping it. So we want to test our server response. And then we want to also time our threads. And you would create a thread pool, right? You saw this before. And then with that, we would loop through because we have multiple threads. And as it does that, it's going to append, it's going to store the threads into this container. And so once you have your thread pool and its container, you would activate the thread by using start. And as we start it, we got to make sure that we join them so that way the others don't execute before, right? So we would coordinate the threads accordingly based on last chapter. So we would then have a for loop for the join. And then we print. Okay, so we want to print out the time. So this is just like the other program. We just added this section with the timer and then our thread pools for multi-threads. Okay, so when we run this, we're gonna get the same response. And so it tells us that it is well, for me, it is about 0.15 seconds. Now, this can vary, right? Remember, when you're working with a destination system, it's really your connection should be a factor. The server connection is also a factor, right? So if I'm testing this when I'm on a slower communication medium, right? Like compare from fiber optic to coaxial or dial-up or something like that, old legacy, right? You're going to see that it is going to be slower even though it is threaded, right? So when we run the function with just sequential, right, like not using multi-thread, my system took about 0.8 seconds, so 0.79 seconds. Compared to multi-thread, we are looking at 0.15 seconds. So definitely a quicker response, even for a ping test. Okay, so ideally, when you're scraping, it would be better if you implement multi-threads and you simply create the thread pool, set up the container, loop through get it to start and then loop through the join. And so you can see the outcome. Okay, any question? Okay, so now let's come back to the assignment. We already talked about how to install. So I'm fine with you doing number 6 with any website. I did test mine with Ubuntu and it didn't like some of it. So I'm going to use Mozilla in this particular demo. Okay, so for number 6, it says refer to the example provided in the notes in chapter 12. Write a program that uses request module to download the HTML code for the web page. So use the first example, and we can use ubuntu.org or any website of your preference. The program must implement request get to get the request to the server and then output the status code on the screen, and we want to screen capture. So this is my number 6. And I can change this up. We can do Mozilla, or if you want to use Ubuntu or any other website, you can try. So use the first example from the notes. So first I have the request module. I have a variable to hold my fully qualified domain name and make sure it is in quotation mark, whether you use single or double, it's the same for Python. And then my variable res is going to be the response. And I'm using the get method from the request module, and I simply pass my URL, which contains my fully qualified domain name. Then I want to print the status code. That's what the assignment calls for. And in this one, if we're doing the same as example 1, we're going to print the headers as well. And since it's asking for the HTML file output, then we want to create or write an HTML file from that website. So I'm going to have a mozilla.html. And so I would use the with open statement, and then I would make it right. And so we can just have it as text. And then we can print done. I'll change this up to finish. Okay, so let's run this now. Let me see. I wonder if it's just from that web page. Hold on. Yeah, I think it's just from, I didn't like the Mozilla one as the encoding is different. Okay, so for the Ubuntu, if you do the Ubuntu, you're gonna see status code. It should be successful, 200. And then your header, it's really simple. Timestamp your server, you can see that it is Apache. So it shows you the product. So Apache is Linux based. And it runs CentOS and it uses OpenSSL. So, and then there is also PHP version. Here is your time to live information. So it's going to do keep alive and then the timeout value. Okay. And then connection and connection type. And then earlier you saw that I was receiving an error from Mozilla. It's because of the encoding part. So it wasn't able to parse it as text when it write the HTML file. So that's why it threw the trace back. So so it could be vary from site to site, depending on how those sites are designed or programmed. So what you would see is that on this one, it's able to give me my Ubuntu.html. So I can check. Right, it's right here. Earlier it threw an error, but it did write partially. So that will be incomplete, as you would see with the Mozilla one and then the Ubuntu one. Okay, so if you're using a website and it's throwing an error because of this part, it's because of the encoding for the HTML file. Any question? Okay, so you can use the example that you see in the notes, or you can refer to this. All right, let's look at number 7. So for 7, we are going to use the second example in your notes. And we are going to use request module. We're going to write a ping test in Python for the site. And now when you testing this with secure website, did you go over the error that you, okay. So I originally have Mozilla like this, right? And I run. So it tells me for mozilla.org, okay? it was successful, but the issue, the hang up is line 11, that it's not able to write the HTML file, right? Because we ask it to create an HTML file called Mozilla, right, from the actual site. So what happened is it tells me right here that for the encoding characters, it is not using UTF-8. Okay. So that sense, because the way that we have it with Python is that it's only going to be able to parse a certain text format with a certain encoding system. So when it's using different character mapping, it's not going to be able to give you the file. So I would suggest to make it simple for you. You can test it with the Ubuntu. Otherwise, you have to specify the criteria on how you want to parse your text in certain encoding format. Okay, so if you test it with Ubuntu, it should work like that. So here, right, my char set is UTF-8. That's the encoding system that site uses. So it's able to give me my text HTML file. And that was the hang up right here for Mozilla. And you commonly see it. So if they're using a different encoding system, like what you saw with Mozilla, different than UTF-8, you often see that it would give you that error. So it's not able to write the HTML file. That's all. It still submit the request successfully. Okay. Other questions? Okay. Now back to 7. We're gonna create the program and we're gonna ping test with our status code. And we're gonna use the get method for the server. So for the ping test, you can use Ubuntu. I think I did Mozilla for this one. Now, if the site has security, sometimes it doesn't let you check a certain status code. You know, the application firewall might block it. So for number 7, just like the example, we're going to do an import request module. We're going to write a function called ping, and we're going to pass the URL list. Our response, our RES, is going to be request.get, and we're going to pass the URL. And then this one we want to test with multiple status code. And then for the URL, you can put in the fully qualified domain name and then follow that with the slash and your status code. So we can do 200, 400, 404, 408, 500, and 524. Like the example. And as it is a list, we got to loop through, so each one will be tested. And then we want to confirm that's done. Now, when you output this, I use Mozilla so that way you can see a little bit different compared to Ubuntu. You are going to get a lot of information coming back, okay, depending on the site. So it's here, what you're going to see is it's going to give me like the content of the site. And for Mozilla, it says, hi there, nice to meet you, right? And then so for each of the ping, it's going to check. So here, let me see. Yeah, so 404, not found. And then, so you're gonna get a bunch of HTML content coming back. As we're printing out, right, the URL in text. So that means that all your HTML code, whatever that it receives, your browser is going to give you that. Now let me test it with, so you see how the Mozilla one is. When I previously did this, should be fine. But sometimes they change things and they block it. So let's check it for the ping. Yeah, it should be okay. So you're going to get, so for each of the tests, when it's successful, you're going to see that it's going to serve you the HTML content, right? And then the 400, the 404, the 408, and then the 500. So it just says not found. And then if you try Mozilla, you're going to get a little bit more. But the whole idea is that with the error ping, you're going to get something back like this. Okay, so refer to example 2 for number 7 in the assignment. Any question? All right, so now you know how to do ping. Okay, so now we're gonna do threaded. I see a chat. Okay, yeah, that works. Good. A lot of the common website that doesn't require like authentication, your HTTP website should work pretty well. Yeah, I normally test it with like the Linux ones or some of the common ones. Yeah, so that works. That's good. Good to know. Okay, after we have number 7, we're going to work on number 8, which is the next example. You saw the threaded example. So we're going to refer to the example. We're going to write a thread pool, and then we're going to still do the ping test. So you can just add to the number 7 by adding some of the section for your thread. And then if you want to do the time, like what it shows, you can see. Okay, so let me get number 8. So the first one, when we run it as a function for the sequential program, right? So here, let's start from the beginning. We have threading. So make sure you import in threading module and then request for our HTTP request and import time. We kept the function for ping the same as number 7. And also you can use the same URL. You just need to add to number 7. So we're going to start the clock. So you would have start is time.time. using the time method. And then we would loop through the URL. So you need to start the clock before the loop. And then we can check to see how long that took just to run it as a sequential program, the first part. So it basically executes this function sequentially. And then we will print. Now we are gonna start the clock again for the threaded part. Then we're gonna have a list for our thread, a loop for our URL. So it's gonna go through each one in the list. And then we're gonna create a thread object. So here, and you in this, we talked about this last week, you're using thread, right, method in the threading module. And your target is always going to be your function. So ping was previously defined. And then your arguments is what you're passing, like what we saw in last lab, right, which is our URL. So we're going to put URL and then comma. And we're going to append each thread. And we're going to activate them. And we would loop through and join them. Then we can print the clock time. So subtract the start, which is this. Then we can run. So my threading for this one took 0.52 seconds. Okay. And then let's look at the sequential part for Mozilla. So much content. Beginning. So that varied also with the website that you use. Sometimes you're going to get a lot more or less, depending on what they have as HTML content. Got lost in the mix of this right here. Let me see. Let me search for it. Actually, yeah, it's not able to find it in the output. Oh, sorry. Anyway, I couldn't find a sequential part. This might be a silly question, but where do the URLs come from? Is it getting the HTML code from the website? Yes, it is getting the HTML code from the website. And where do the URLs come from? The URLs are just basically any website URL that is publicly registered. So you would use, like, for example, like for yourself, you use W3C schools, right? And then the status code for each part. So when it passes the URL, whatever that you put in this list, that's what it's going to plug in. So for the threads, you're going to have, it's going to submit it all at once. So that way it's going to be faster than you doing it. So it's kind of like how you open up your browser and you typing in individual URL, right? So we want to check to see if it's successful, if it has error. I don't know if that answers your question, but you can use any fully qualified domain name that's publicly registered. And so I can have, for the ping, what we're doing here is we're pinging the same website, right? But in the case where if you want to ping multiple websites, yes, you can have it all in one list, and it will just use the loop to start and activate the threads. So you would have, it would submit that to the server for every single one of them. Okay. You're welcome. Okay. So in this one, we added the thread portion, and as you can see, right, ideally that would be quicker than having just, going through each request, each get sequentially. Okay, then for 9, refer to the example. We are going to use threading module again. But what we want to do in this one is we want to put in a threshold. So you wanted to make it where it would only be able to submit the request within 10 seconds, right? For each of the codes. So we're only going to do 200 and 400. We don't have to do all of them. Okay, so we're still going to do the ping test, but we're only going to make it do within the 10 seconds. So you would give it a time window, because in the case where if it has a longer delay, right, it's going to come back and let us know that is not responding. So let's see, I have 9. Let me double check something here. So for number 9, refer to page 7 on your notes. This is a good example for you to use. Okay, but I'm going to run through my my program so you can see. Now, what we're going to do is we are going to make this an object-oriented program, right, with class. We have threading, we have request module, we have time module. Those are important. You're going to define your class, my thread, okay? And this is going to be threading.thread. So this is where you're going to create your threads, and also we're going to initialize our member variable that's going to hold the URL, or member list, I should say. But for this, the result, I wanted to put none. Then I have, so in the class, when I define my class, I would define an init function, right? And since I'm using the argument URL, I want to say self, comma URL. And for this init function, I need to set up for the module, because I'm using the module threading. It's superclass. So I would say threading.thread, and then I also need to set up init cell. We talked about this before. Then here are the members. Then I have a member function called run. So I would define run. And in the function run, I would define my response, or res. That's going to be storing the result from get. So I would say request.get and the parameter we would use self.url. This is the argument. Right, from here, bring it down here. Then for the self.result, earlier we put none because simply we just create a placeholder. Now we're going to fill it in, right? So for the result, we're going to say self.url, and that's going to be res.text. So the response, it's going to keep it in text format, and it's going to store that into the result. Then for my URL, I have a list, and here I'm using ubuntu.org. I want to test with 200 status code. And as the assignment require, I want to make it timeout with 10 seconds. So I would, for the second URL, I would put the same as the first, but in this, I would use the question mark, and I would add, so this operator allows us to also use an additional requirement. That's going to be the timeout, which is 10 seconds. So we would put 10,000. As normally it would use milliseconds, right? And then I wanted to test it with the error code, which is 400. We're going to start the clock. So start is going to be time.time. Then we're going to make our thread pool. So unlike the last exercise, this one, our thread pool, because we're using a class, you got to bring in the class, which is now a type. So our threads is going to be a list. And in that, we are going to say my thread URL. And because it's Python, we can loop within that container. So we can say for URL and URLs. So that means that it's going to contain every single element, right? Which is your URLs. And as we loop through that, we are going to also need to loop through the thread. So that way the threads can be dedicated to submit the get for each of the URL. So one thread can handle one URL. That's what we want to do. So once we have the thread pool, we need to start them. Then we need to join them. And then we need to print the result for each thread. And then we would print out the time difference. So in comparison with the last one, this program is slightly different in that we define a class. We have an additional, inside that class, we have a member function. Now the URLs is less, so we're only checking 200 and 400, but for the 200, we're going to make it timeout. We're at 10 seconds. And in this one, when we create the thread object, which is a list, we have to bring in your class, which is my thread. Okay. And we would loop through the start, we would loop through the join, and we would loop through for the result. So you're going to get response back for the website, right? 404 is not found. Then we have a time sweep here. It shows the content that it is successfully submitted that request, right? And then, if it exceeds 10 seconds, it's going to sleep or wait. So then it serves me my HTML content from that website. Okay. And then it tells me that altogether for the threads, it will be 0.27 seconds for me. Now you can, for practice purposes, we're using 10 seconds, but you can also think about the time window that you need. And so so this shows you how you can program it for the timeout. Any question? I really like web scraping and web things and working with APIs because I really enjoy like utilizing like it really forced me to apply all the concept that I know about communication and server networking, even security. Um and so and now you see that most companies, most organizations implemented web servers, and whether they outsource it or they in-house it, you still see that to really support, marketing and other things about the company. But with that, we can think about how we can automate a lot of these things, or when we need to pull data, or when we need to test our servers. And if you take the security class for Python, CIS30C, which is not offered in spring, it will probably be the fall again. But the other two are going to be available. You would see that we spend quite a bit of time also in the web area because that's a much needed area for cybersecurity. Okay, so this, you can refer to the example. The only difference from my program to the example is I put in this piece. Okay. All right. Any question? Okay, so we did 9. Now we're gonna try to wrap up with the last part. Oh yeah, so I did give you an example. So refer to page 8 for number 9, not 7, page 8. It shows you that here. Okay. So in this one, it uses 20 seconds timeout, so 20,000. So whatever the time window, you just need to modify this value right here. So another way that we can also track timeout is to look at, to use the isAlive method. We saw this in the last chapter when we talked about thread. So the example that you see here, you see that it does sleep for 4 seconds and then 20 seconds here for the timeout. But you can also create the tracking mechanism with the while loop. So in this program, we would implement a way to track the request. So there's a function called or a live count, and it's going to track the threads by using isAlive method. And then for the while loop, it's going to have it's going to use the isAlive or a live count method. When it is greater than 0 and timeout is greater than 0, then it's going to decrease the timeout. So it's going to update the interval because we would have less time as we proceed. So I would have 10 second, 9 second, 8 seconds, and so on. Which page? Okay, you would refer to page 8 of the notes. But the example on the next page, you would see that it is a way that we can track our threads, right? To see how the timeout works. And so you would decrease the time as you proceed in the loop, because as you know, we would have less time when we move forward. So what you would see is it's going to update the interval. And so with that, you would have it's going to update the sleep as well, which was used here. So for web requests in general, and this can be expanded much more, right? For the chapter, we focus on how to write the basic program. We expand it into threads, and then we would be able to implement like timeout and also tracking timeout. So when you're collecting data with web scraping, you need to really review the policy or the rules on the website on how you can obtain. We can't just go and scrape from everybody, right? We want to make sure that we are following the rules, because sometimes when you're pulling the data, that might be illegal. So you might have to ask for permission. So look at how you can scrape based on the policy, what's allowed. Okay. Then we need to think about exception handling. So your error handling is important. So when you write your Python program, think about how you would implement try except or have exception handling blocks. Okay, you can still accomplish the same thing, but you can have it try and except. So in the case where it generates the error, it doesn't stop. It will either notify you or move forward, right? As we want to build these tools for automation. And then because website changes all the time, like what you've seen, and we are facing the same problem this semester where I tested it last time and it works, and then sometimes contents are changed or removed. So you would need to update your program. So API might work like now, but a few months from now or next year, it might not work again. So looking at how the changes and its logic is implemented, and you need to make sure that you update your program. Okay. And that's kind of like a downside, is that you do have to frequently modify your program based on the changes on the sites that are out there. And when you're dealing with large requests, like I mentioned about denial of service, or distributed denial of service. So if you write a script that handles hundreds and thousands of requests, some site will block it as threat. So their firewall is going to see that as, that you're scraping too much from the site, or you're submitting way too many requests, because it does have a threshold in the firewall. It's going to say that, more than 5 requests from a certain source, from a certain IP address is too much, right? So it might kick you off. So think about like how that can be perceived as an attack. Okay. And then on your end, when you're submitting requests like that, it's going to bog up the bandwidth and the traffic from your network, because it still needs to route out your requests, right, to the routers and then eventually to your service provider. So in that case, your heavy duty requests sometimes can be perceived as attacks and or flood. So we want to make sure that we are mindful of that when we're submitting large requests. I know that it's convenient and it saves time, But just to prevent issues, you should think about how to chunk it up, right? We might need to run multiple scripts or run the scripts like in various time instead of just if you're submitting like, let's say 1,000 requests at once. Think about the bandwidth that you're going to use up for that. So in a network, when we use up all the bandwidth just for web scraping, then that leaves the rest for other things that might be important, like streaming or, voice, or, if we have customer service or call center. There are things that are needed to be able to handle live customer compared to just web scraping. So you have to prioritize on what you're using inside your network. And especially when we're thinking about using script to automate a lot of things, such as handling web requests. Okay. All right. So here it tells you that it is important to space out concurrent requests, even if you're using multi-threads. So kind of just, set it up where it runs it periodically or in various time instead of all at once. And then limit the number of requests to implement by using, you can have it delay, and we can automate it by putting in time.sleep. And so I can have it pause for, let's say, 15 seconds. So that way it doesn't make it look like it's just a flood of traffic coming through. Okay. So on the security side, that's usually when you see like a bunch of requests like that, when they do network monitoring and server monitoring, right, it usually blocks it because it's coming from the same port. Yeah, web is the easiest way to get into, the public side of the network. So that the threat is usually set up pretty consistent for the rules in the firewall, as you can see. Okay, so you can take that portion here, you can summarize it, you don't have to put it verbatim, but the whole point is to make sure that you understand, right, the concept on how we would apply this and what will be mindful as far as practices for the industry. So I put that you need to look at your terms of service when you're collecting data. And if it's not clear, you can just contact the provider, right? The website company, and then ask when something is vague, right? Don't assume. You should always ask, because the legal side is that if you're doing it illegally and they don't authorize it, the consequences is going to be fines, or sometimes it's worse, right? So we want to make sure that we review the term of service and then contact for additional rules and guidelines. So they'll tell you how. And then we should use try and accept block to manage error or handle exception to avoid application crashing. We would update the program regularly to accommodate changes to our websites that we're scraping from. And then just to avoid making large requests, because that looks like attacks. And you can implement time.sleep to space out your requests. Okay. So those are the things to think about when you're scraping. And I know that some of you are going to go into data science, and this is an area that you can use with Python for pulling data. And, after that, you still have to clean and do other things and, format your data and all of that good stuff. But that's also a separate area in Python that you can tap into. But definitely a useful tool in all aspects, whether you go into development, data analysis, or cybersecurity. And as cybersecurity is my forte, I usually have more explanation and things that will relate to that, because I know that best. But I do know some other area as I work with, some part of that. So, okay. So not too long of an assignment today. Check out your notes, go through, look at the code. And then I know Jimmy brought up an issue with the lab for one of the exercise, so I'll look through it tonight. I'll work on it and then I'll address it either via email or in our lab session next time. So as some of you are working ahead, okay? All right. Okay, let me stop recording.